In this question, calculate the depression in the freezing point of water when 10 gram of 2-chloro-butanoic acid is added to 250 gram of water. Dissociation constant is given and freezing point constant is given. And we have to find the depression in the freezing point. So let's make a plan how we will solve this question. So here in this question, we have to find a delta TF. It's equal to I into KF into M. So here I is not known, this we don't know. KF is known, this we know, and molality is not known. So here this I and molality first we try to find and then substitute in this relation. So let's first solve the molality. So we know that molality is equal to mole of solute divided by mass of solvent in kg. So our solute is 2-chloro-butanoic acid. This is the solute here. And solvent is water. Now we have to find the mole of solute. So mole of solute is equal to mass of solute divided by molar mass of solute or molecular mass of solute. So in the question, mass of solute is 10 gram, it's given. So we can substitute it here, 10 gram. And the molar mass is equal to 122.5 gram per mole. We can find it by calculating how many carbons we have. So 1, 2, 3, 4. So 4 into 12 plus how many hydrogen? 3, 2, 5, 6, 7. So 7 into 1 plus oxygen is 2. So 2 into 16 and 1 chlorine. Chlorine is 35.5. So based on this, we can write it as 48 plus 7 plus 32 plus 35.5. It's equal to 122.5 gram per mole. It's equal to 0.326 mole per liter. So now we know the value of molality. Now we have to find the value of I. This is Van 't Hoff factor. So how we will find the Van 't Hoff factor? So to solve this Van 't Hoff factor, we need to see how this reaction is done when we are breaking the 2-chloro-butanoic acid. So let's write down the reaction. So this is our reaction. Here 2-chloro-butanoic acid get dissociated into positive and negative ions. So let's assume that when at T is equal to 0, when the time is 0, that time the concentration of reactant is C and the product concentrations are 0. So if we consider at equilibrium, there is some change in the concentration of the reactant and the new concentration is C minus C alpha. This is C alpha and this is C alpha. How we are getting, what is alpha here? Alpha is degree of dissociation. It means that how much percentage of this 2-chloro-butanoic acid is getting dissociated. So this is our remaining concentration. So if we have to find the Van 't Hoff factor, so we can use the formula I is equal to total concentration after dissociation divided by total concentration before dissociation. So here, what is the total concentration after dissociation? So you see here, this is our concentration of the reactant and these are the concentration of product. So we can say that total concentration after the dissociation, we can add all of it. So C minus C alpha plus C alpha plus C alpha, it is equal to C plus C alpha. So C 1 plus alpha. Total concentration before dissociation is C. So now if we substitute the value here, we can write it I is equal to C1 plus alpha divided by C. So C gets cancelled. It's 1 plus alpha. So I value, we found it as 1 plus alpha. But in the question, this degree of dissociation is not given. So this is our another work. We have to first find the degree of dissociation. So then only we can utilize that relation and find the Van 't Hoff factor. So what is degree of dissociation? Formula based on the given value. So in the question, K alpha is given. Dissociation constant is given. So if we have to find the degree of dissociation constant is equal to the concentration of the product divided by the concentration of the reactant. So it means that we have to use a formula here. C alpha, it's a concentration of the product, and this is again C alpha divided by C minus C alpha. So we are using this relation to solve. So here this can be written as Ka is equal to C square alpha square C minus C alpha. It's equal to C square alpha square by C common 1 minus alpha. So C gets cancelled. It's equal to C alpha square divided by 1 minus alpha. So here what happened? This 1 minus alpha, we can assume it's almost equal to 1. Why? Because 2-chloro-butanoic acid is a weak acid. So due to the weak acid, its degree of dissociation alpha is very small. Because this value is very small, so 1 minus alpha, if you subtract it, almost equal to 1. So now we can write it as Ka is equal to C alpha square by 1. So this is our relation. Now in the question, Ka is already given. This is known. So we can substitute the value. Ka is equal to 1.4 into 10 to the power minus 3. So if we substitute it here, Ka as 1.4 into 10 to the power minus 3. C is the concentration. So C into alpha square. So we can find the alpha square. So what is the value of concentration? So here concentration is nothing but the molarity. So here molarity will be equal to molality as water is a solvent here. So in this case, mass of water will be equal to the volume of water. So based on this relation, we can say that molarity is equal to molarity. If you need further explanation, I can explain you. Molality is equal to mole of solute divided by mass of solvent, and molarity is equal to mole of solute divided by volume of solution. So here the solution is basically water. So as I told you previously, the mass of water and the volume of water will be same. It means that these two terms will be same. So their values will be also be same. So that's what molarity and molality will be equal. So now we already found that molality is equal to 0.326. So we can substitute the value here. 1.4 into 10 to the power minus 3 is equal to 0.326 into alpha square. So based on that, alpha square is equal to 1.4 into 10 to the power minus 3 divided by 0.326. So alpha is equal to root of 38.6 into 10 to the power minus 4. So alpha is equal to 6.21 into 10 to the power minus 2. So now we have the alpha value. So alpha value, if we substitute in the place of I here, So I is equal to 1 plus 6.26 into 10 to the power minus 2. So it's equal to 1.0621. So I value now we have. So this I value we can substitute in our relation here. So delta TF is equal to 1.0625 into KF is 1.86 into molality is 0.326. It's equal to 0.65 degree. So this is the answer of this question.